Assalamualaikum warahmatullahi wabarakatuh. Good morning or afternoon. On this occasion, I would like to present my research entitled Application of Supervector Machine and Kenner-Snigger Algorithm for Early Detection of Diabetes Risks with Shapley Additive Explanation Interpretation. The outline of this presentation will explain the research problem, research question, model interpretability, methodology, classification method, interpretation, research significance, and conclusion of the study in the context of healthcare and machine learning. Research problem. Diabetes is a chronic metabolic disease and has become a major global health concern. According to the International Diabetes Federation, the number of adults living with diabetes reached 589 million in 2024, and it's projected to increase to 853 million by 2050. A critical issue is the high proportion of undiagnosed diabetes cases, which approximately 42.8% of patients are unaware of their condition. If diabetes is not detected at an early stage, it may lead to a serious complication such as cardiovascular disease, kidney failure, nerve damage, and vision impairment. Therefore, early detection is essential to reduce complication and improve patient quality of life. In recent years, machine learning has been increasingly adapted in the medical domain to support diagnostic decision making. Machine learning algorithms can analyze clinical data such as age, glucose level, body mass index, and blood pressure to predict disease risk efficiently and accurately. Researchers Saranya and Pades said, among various classification methods, support vector machine and Kennery's neighbor are commonly used for diabetes prediction due to their effectiveness and relatively simple implementation. However, previous studies report inconsistent performance results. Some studies by Kangra and Singh indicate that superfactor machines perform better, while others show that KNNs achieve higher accuracy. It's by the Omulet researcher named Omulet in 2023. This inconsistently highlight the need for a comparative evaluation. Based on the research problem and identified gap, this study proposed the following research question. First, which algorithm, superfactor machine or Canary's neighbor, is expected to provide a better diagnostic performance for early diabetes risk detection using PIMA in this database diabetes dataset? Which clinical features are expected to have the most significant influence on model prediction based on interpretability analysis using simply additive explanation? This research question guide the selection of methods, evaluation metrics, and analytical approach in this purpose study. model interpretability. Despite their predictive capability, many machine learning models suffer from the black box problems, where the prediction result cannot be clearly explained to the medical practitioner. To address this issue, the research proposed the integration of explainable AI, specifically supply additive explanation. SHAP will be used to analyze the contribution of each clinical feature, such as glucose level and body mass index, to predict the diabetes rates. By applying SHAP, the proposed bundle is expected to improve transparency and interpretability, which are critical for potential clinical adoption. Methodology, data, and processing. This study proposed to use the PIMA India's diabetes dataset, consisting of 788 68 female patient record, 8 clinical attribute feature, and 1 binary target variable. The proposed research stage include data preprocessing, including the median imputation for zero or missing values, and then filter scaling, considering the sensitivity of SVM and KNN the filter magnitude to filter magnitude. Data splitting, using an 80% to 20% split ratio for training and testing with specified sampling. Classification methods. The proposed classification algorithm are k-nearest neighbor, which classifies data based on the nearest neighbor, and then support vector machine, which identify the optimal hyperplane with maximum margin. Model performance will be evaluated using accuracy, precision, recall, and F1 score, which are appropriate metric for medical classification tasks. Interpretation. Why we using SHAP? So, SHAP, after evaluating model performance, SHAP applied to explain prediction result. SHAP is used to first identify the most fundamental feature at a global level. It's like the general, the common, the most common for everyone, and then explain individual prediction for a specific patient. So we can do for a specific each patient have a specific explanation. This approach help answer clinical questions such as is glucose more influential than body mass index, and how do change in feature values affect diabetes rates? This is consistent with the recommendation of previous researchers who emphasized the importance of interpretability in medical prediction systems. Research significance. Providing a providing a empirical comparison of SVM and KNN on clinical dataset. And second, integration of explainable AI or SHAP to enhance clinical trust. These contributions are expected to support future research and potential clinical application. In summary, this research aims to evaluate and compare the SVM and KNN for early diabetes risk detection while addressing the interpretability challenge through SHAP. The, the proposed approach is expected to produce a predictive model that is not only accurate but also transparent and clinically trustworthy. That concludes my presentation. Thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.